Hello everyone and welcome to my channel Maths with Lazy Bee. In this video, we'll be discussing this question, which is of permutation and combination. The question says that we have 9 students, S1, S2, S3 till S9, and these 9 students have to be divided in 3 teams, X, Y, and Z, such that X has 2 students, Y has 3 students, and Z has 4 students. And there are 2 conditions given that S1 should not be there in X. While choosing students for X, S1 should not be there. S2 should not be there in Y. So now we have to find the number of ways to form such teams. Okay. So while starting the question, okay, let's first mention the students. S1, S2, S3, S4, S5, S6, S7, S8, S9. Now we'll be making a choice, or we will have to decide something. Now, okay, so S1 should not be there in X. So that means while choosing for X, S1 should not be included. So now we have 8 students, S2, S3 till S9. We have 8 students and it is very easy to make a choice for X. How? 8, C, 2. We need 2 students in X now. So out of 8, we can choose 2. And we'll be using combination here because the choice is not dependent on the order. Whether we choose S2, S3 or we choose S3, S2 doesn't matter. Students are the same, right? Order doesn't matter here, so combination question. Okay, so we are able to figure out that it is a combination question, and because of the condition given that S1 should not be there in X, it is decided that out of the rest 8 students will be choosing 2. Okay. Now, while choosing Y, how are we going to decide? We don't know. The way we have chosen 2 out of those 8, we can't say that whether S2 is still there or S2 is not there to be selected. See, there is a problem here because I haven't distinguished the cases. We don't know. We have randomly chosen 8 students, or even we had made a choice intuitively, logically, but we have just chosen 2 students out of those 8. Whether S2 is there or whether S2 is not there, right now it is not clear. The best part of the permutation and combination is that when you are doing the question, when you are solving, you get to know yourself whether you are doing it correctly or not. Your cases or your choice, the way you write the combination, permutation, the way you decide it in your mind, it makes it very clear whether you are answering the question in the right manner or not. So the way we chose 2 students out of 8, it is not clear right now that S2 is there in Y, in X or not. If it would have been clear, now it should have been easy for me to choose these students for Y. Are you understanding what I'm trying to say? That it was very easy for me to make a choice for X because the condition is that S1 should not be there in X. So we can exclude S1 and we can choose from the rest 8 students. We can choose 2 students from the rest 8. But the problem comes when I have to decide it for my Y team. Because right now, okay, so we have 8 students. We had 8 students. We chose 2. So we had 6 plus S1. Okay. We have now 7 students. But we don't know. We can't simply say that let us take S7, 7C3. We can't do this because 7C3 means because choosing these students for Y out of those 7 remaining. We can't do this because those 7 might include S2. So S2 is creating a problem. So why not make 2 cases and finish this problem of S2. This is going to be the best thing. Now, by making cases means that take two cases. First one says that S2 is taken in X. And the case 2 says S2 is not there in X. These two cases will make it easy for you to go or to solve this problem. How? You will see. So case 1 says that S2 is there in X. While choosing the students for X, I have already decided that S2 is there in X. Now, S2 is taken, see the yellow pen, yellow ink, yellow color. S2 is taken in X. And S1 should not be there in X. And we have to fill 2 slots for X. S2 is fixed here. So how many students need to be taken or chosen right now? One, only one. And how many choices do we have? Or how many remaining students do we have? We have S3, S4, S5 till S9 because S1 should not be there. S2 is already taken. So S3, S4, S5, S6, S7 and S8 and S9. Out of these 7, S3 till S9, we have 7 students. So say S3 and name this set as S. So we have 9 students. Out of these, we have 7 students. Out of these 7, we need just one. We have to fill 2 slots in X. So we need S2 is already taken. So just 1 slot is remaining. So out of these 7 students, we need just 1 student. So 7 C1. So this is for X. Now multiplying. Why multiplying? Because right now we are dealing with the same case, same event. We are doing it simultaneously. This is not a second case or second stage where we took X choices for X and then in the second stage or second event. No, we are doing it simultaneously. We have already taken students for X and now we are deciding it for Y. So it is multiplication, not addition. We are dealing with the same event, same thing, same case. So now how many students are there? 7 C1. Okay. Now how many students are there for Y? S2 is already there in X. It won't be a problem now. S1 is remaining. S1 is remaining. Because S1 should not be there in X, so it remains. It is a candidate. It can be chosen. And out of the 7 elements of those set S, we have chosen just 1. So that means we have remaining 6 students. So S1 plus 6. We have 6 students. 7 students. S1 plus 6, we have 7 students. Out of these 7, we need 3 for Y. And you can do the calculation. You'll get 245. You'll get 245 ways. So we have 245 ways in which this can be, this case can be dealt with. Okay, this case can be dealt. So what happened? Let me tell you once again. We had 9 students. We had to choose students in 3 teams. We have to distribute students in 3 teams, X, Y, and Z. Such that X has 2 students, Y 3 and Z 4. But the conditions are that S1 should not be there in X and S2 should not be there in Y. So earlier, initially we started that, okay, since S1 should not be there in X, so we have remaining 8 students. And out of those 8, we can choose 2 for X. But that was creating a problem when we were doing or we were selecting students for Y. But because we didn't know whether those 2 students, whether those 2 students had S2 or not. So that was a problem. So whatever is the problem, consider cases. Okay. So what we did, we took first case that S2 is there in X. I have already fixed S2 in X. Now, since we have to choose two students for X, one remains to be chosen. And remaining we have 7 students because S1 is out of consideration. S2 is already taken. So out of those S3 till S9, we have 7 students. Take one out of those 7, 7C1. Now comes for Y. While choosing for Y, how many students do we have? S2 should not be there and S2 is already there in X. So it won't be counted again. Okay. S2 is already there. S2 case is fixed. उसको फिक्स कर लिया हमने, अब उसका कोई काम नहीं, चला गया वो, अब कंसिडरेशन में ही नहीं है क्योंकि वो तो एक्स में आ चुका है। एक ही बच्चे को हम बार बार तो अलग अलग टीम्स में नहीं डाल सकते ना कि वो एक्स में भी है वो वाई में भी है, वो नहीं हो सकता। S2 फिक्स कर लिया हमने, तो अब S2 की कहानी खत्म हो गई। S1 बचा है, S1 एक्स में नहीं जा सकता था तो S1 बचा है, और वो 7 स्टूडेंट्स जो एस में थे उसमें से एक लिया था बस, तो 6 बचे हुए हैं। So 6 plus S1 equals to 7 students, and out of those 7 students, we have to choose 3 for our Y. So this case gives us 245 days. Now coming on to the case 2. जब केस 1 में क्या लिया कि S2 X में नहीं है, तो केस 2 में क्या, S2 X में है, तो केस 2 में क्या लेंगे कि S2 X में नहीं है, S2 is not there in X. Case 2 says S2 is not there in X. So we need 2 students in X. S1 नहीं होना चाहिए, S2 है नहीं, ये मैंने डिसाइड कर लिया। तो कितने बच्चे रह गए? S3, S4, वही हमारा जो सेट S था, S3 से लेकर S9 तक, we have 7 students. S2 should not be there, S1 should not be there, and S2 I am not taking. मैंने बोल दिया कि मुझे नहीं चाहिए X में S2, तो फिर मैं किस में से चूज कर सकती हूँ? मैं 7 स्टूडेंट्स लिए जो सेट एस है, इसमें से मैं 7 बच्चों में से मैं अपने 2 बच्चे पसंद कर लूंगी, फिर मैंने रख दिया 7C2. Now it's Y's turn. While selecting students for Y, now we have to take care of S2 because S2 is not yet there in X. We have not selected S2 in X. So now S2 should be taken care of. But how many students do we have now? Since we have already taken out 2 students from the set S, initially we had 7 students. 2 चले गए, बस 5 रह गए। और S2 नहीं लिया, S2 भी बचा हुआ है, और S1 तो X में जा ही नहीं सकता था, वो तो बचा ही हुआ है। तो कितने बच्चे रह गए? 5 plus S1 plus S2. That means we have 7 students. But what the condition says in question, that S2 should not be there in Y. So that means we have 6 students remaining. And out of these 6, we will be making our choice for Y. And the choices that we need, only 3 students for Y. So out of these 6, choose 3 for Y, and we will get 7 factorial, 2 factorial, 5 factorial into 6 factorial, 3 factorial into 3 factorial. That means we have 21 into 20, 420 ways. 420 ways. As case 1 gave us 245 ways, case 2 gives us 420 ways. So in total, we have 245 plus 420 equals to 665 ways. Also, since while selecting students for X and Y, 2 were taken in X, 3 were taken in Y. So 4 students were already chosen, and we don't have, sorry, 5 students were already chosen, and we don't have any extra students. Only these 9 students need to be distributed or divided. So whatever remains is put in Z. 5 students are already considered, 4 remains. So 4 are put in Z. In both the cases, this happened. Just giving a quick summary. Although you are intelligent students, you might have understood it till now, but the question says that we have 9 students, S1, S2. S1, S2, S3, S4, S5, S6, S7, S8, and S9. We have 9 students. These 9 students have to be put in 3 different teams, X, Y, and Z. X should have 2 students, Y should have 3 students, Z should have 4 students. In a manner that S1 is not there in X, S2 is not there in Y. So what are the number of ways to form such teams? If we had just blindly started, like if S1, just S1 should not be there in X, that means we have 8 students. Out of 8 students, we can make a choice of 2. So 8 C2. But after doing this, we'll be having problem while choosing our students for Y. The problem will be that while selecting 2 students for X, we don't know whether S2 has already been taken or it is yet to be chosen, whether it is there or it is already selected in X. So that was creating a problem. Whatever creates a problem makes a case. We made 2 cases. Case 1 says that S2 is there in X. S2 को X में डाल दिया हमने. इससे हमारी फ्यूचर की प्रॉब्लम सॉल्व हो गई. कैसे सॉल्व हुई? अब बाद में टेंशन लेने की जरूरत नहीं है कि Y में S2 कैसे डलेगा, पता नहीं पहले ना चला गया हो, ऐसा नहीं हो रहा. तो क्योंकि S2 हमने पहले ही ले लिया X में, तो हमारे पास सिर्फ 7 बच्चे रह गए, क्योंकि S1 तो आना ही नहीं है, S2 ले लिया है X में, तो 7 बच्चे रह गए. 7 में से 1 चाहिए क्योंकि 2 ही बच्चे लेने हैं X में, तो 7C1. फिर Y का सोचा. After choosing students for X, we have 6 students remaining in the set S, and S1 is also remains. So S1 plus 6, we have 7 students. Out of those 7 students, now since S2 is not to be considered, S2 का तो प्रॉब्लम सॉल्व कर ही दिया है, तो उन 7 स्टूडेंट्स में S2 है नहीं अब कहीं पे, तो आराम से 3 स्टूडेंट चूज करो, कोई प्रॉब्लम नहीं है. तो आपको टोटल वेज मिल जाएंगे, 245 वेज मिल जाएंगे. देन मूविंग ऑन टू द केस 2. केस 2 में लिया वही जो केस 1 में नहीं लिया, कि S2 X में नहीं है. केस 1 में लिया था कि S2 X में है. अब जब हमने सिलेक्ट किए बच्चे X में, S2 is not there. I have made a choice that I won't be selecting S2 in X. और S1 तो लेना ही नहीं है, तो कितने बच्चे हैं? S3 से S9 तक 7 बच्चे हैं, 7 स्टूडेंट्स हैं. Choose 2 out of those 7 students for X, because we have to decide, we have to choose students for X. So 7C2. Now what all, how many are there? We have taken 2 from the set S, so we have just 5 students remaining. 5 students remaining, and S1 is also there, S2 is also there. क्योंकि S2 तो X में लिया नहीं मैंने और S1 तो ऐसे ही नहीं लेना था, तो 5 बच्चे S में से बच गए और S1 S2 बच गए। लेकिन कंडीशन क्या है कि मैं वाई में S2 नहीं ले सकती, तो ठीक है, नहीं ले सकती तो पहले 7 बच्चे रह गए थे, 7 स्टूडेंट्स आ रहे थे, अब 6 स्टूडेंट्स में से चूज कर लो क्या आएगा। 3 बच्चे चाहिए 6 में से, तो 63। और क्योंकि सेम ही केस है, सेम इवेंट चल रहा है, मल्टीप्लीकेशन आएगा, एडिशन नहीं है। 7C2 into 6C3 will be getting 420 students, 420 ways, and in total you will be getting 245 plus 420 equals to 665 ways. Thank you so much, and see you soon in the next video.